Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about profit, cost, and revenue. More specifically, we're going to talk about how we can do things like maximizing revenue, maximizing profit, and minimizing cost. So we've been talking about in calculus a while how we can maximize and minimize functions. So we're going to apply those ideas just to these different given functions. So let's first start talking about an easy one, and let's minimize cost. So that's a very obvious idea. It's something that we like to do. It's kind of just human nature to want to minimize cost. So if we're given a cost function, we could find the derivative function and minimize the cost function. That just has to do with minimizing and maximizing different values with critical points and values. So with this, if we have c prime of q, we just need to set it equal to 0 and find that q value. So what this says is if c prime of q equals 0, saying that there's a critical point, and the derivative switches from negative to positive, then we can minimize cost. So what that is if we have a function, cost, and we want to find out where it's minimized. Now, keep in mind that this is local min, local max, but this actually does help because we're kind of concerned about how the surrounding values affect the cost. So at this point right here, we know that's a local minimum. So the derivative at that point, c prime of q, equals 0. Now the second part says, if this switches from negative to positive, such as this, then we know we have a local minimum and we've minimized cost. Now that's the first derivative test. The second derivative test says when c prime of q equals 0 and the second derivative is less than 0. So what that says is this part's the same, c prime of q equals 0, but this part from the second derivative test says that it will be concave up in that location. So if the second derivative is less than 0, then we know that this is going to be a local min, and therefore we've minimized cost. So now let's talk about maximizing revenue. And it's going to be the exact same idea. So if we maximize revenue, once again we're going to have our r prime of q equals 0, and we can say that the derivative will switch from plus to minus. So this example would be like this. The derivative there is 0, and we're switching from plus to minus. That's the first derivative test. Now the second derivative test, once again, just checks that the derivative there is 0, but the second derivative is greater than 0, therefore signifying that that is a local max. So, in this case, we have a local max and we've maximized revenue. So now let's take these two ideas and let's combine them together. And I talked about this a little bit in the last video with maximizing profit. We know that we can maximize any function by finding its derivative and setting it equal to 0 and solving. So right here that just says marginal profit. We want to find out when that equals 0 and when p prime of q switches from plus to minus. Very similar to maximizing revenue before. And the same idea here, if the second derivative is greater than 0, then we know we've also found, once again, we've maximized profit. Now there's one other thing I'd like to talk about. Previously I mentioned that when marginal revenue equals marginal cost, then we've maximized profit. But why is that? Well, we know that profit equals revenue minus cost. Now, if we take the derivatives of all those, we have marginal profit equals marginal revenue minus marginal cost. Now, we just spoke earlier, and I just mentioned that when marginal profit equals 0, we're going to maximize profit. So if this is 0, then marginal profit minus marginal cost must equal 0. So in that case, we can just solve this and bring that marginal cost to the other side, and marginal cost equals marginal revenue. So as I said in the previous video, when marginal cost equals marginal revenue, we've maximized profit. In the same way that we've been able to take marginal profit, set it equal to 0, and solve in that way. So given two separate functions, cost and revenue, we can visualize it on the graph by finding when they're equal to each other. But if we're just given the profit function, it makes more sense to just solve for the derivative, set it equal to 0, and solve. So this has been kind of talking about revenue, cost, and profit, and how they all connect with each other, and how the derivatives of each of them can help us maximize and minimize different things in that order. So hopefully it's been helpful, and we'll see you next time.